Hello, welcome to another rigging update. I only just released the update to the Land Rover yesterday, but I'm ahead of myself, and the character's been started. And so far, I just want to talk about the legs. Well, that's all I've rigged at the moment, but this is the current state of the character. So, as you can see, we've got some bones going on. Got some controllers, and it's fairly similar to the car, except now we are deforming things a bit more organically. Whereas with the Land Rover, um, the doors, well, the wheels and the doors, everything was fairly mechanical. So the weight painting was fairly easy. You just assigned it to that one object, and to that joint, and it was a one-to-one basically. But with the character, we've got to explore more things like deformation of, where the leg bends here, and I'll talk about that later. But for now, we'll just look at the bones and see what's going on here. So the setup here is we've got basically where the starts at the hip here, and then we've got a chain of bones going all the way down to the foot. And ideally you want to have a continuous direction of where the bones follow down, and as you can see, the orientation of this bone has Y pointing down, and that Y is consistent throughout, so it's always pointing down the bone. And you can achieve that quite easily through just in the skeleton menu, you can have orient joint, and you can choose the axes to orient, and you can also orient it to the world if it becomes unaligned. And by doing that, it's just to allow consistency, that when we rotate things on the X, we know it's going to rotate this way, whereas if we rotate it on the Z, we know it's going to rotate that way, and so forth. And again, it's just to make sure that everything on the character is consistent, there's no discrepancies, and later on there might be something you're trying to rotate and you end up rotating it the wrong way. It just saves you a lot of hassle down the line. So you want to make sure that the orientation of the joints is correct. Now the structure of this is fairly basic. You just sort of place the bones in this leg fashion. We've got a upper thigh and then lower leg down to the ankle here, and then if I just don't know why the bones are so big right now. We just pull down. Oops. Just pull down this joint size a bit. There we go. See what I'm doing. And so yeah, that comes down into the foot, and then we've got a toe at the very end. So from here, we could start applying this to the character or the mesh, but it would be a hassle to rotate each bone when the animator's animating. And the cool thing about 3D animation is that rigging is that you can put in these what are called IK solvers, and what this allows us to do is essentially have one thing affect another. So for example, when I lift this foot up, this knee will bend in regards to the distance. Probably calculates it between the distance between these and then how far that needs to rotate. And as you can see, that works quite fluidly. And obviously it's going to start freaking out if you start to go beyond certain limits. Ideally, if you're giving this to an animator, the maximum translate we could have really is about 26 or even 21, about there. Again, that could be adjusted in the limit information. And again, that comes down to common sense. If something starts stretching too far, or humanly impossible things to do, like that, well, you're obviously not going to do that. So from here, there's one IK here to solve for the knee, and then there's two more IKs. So we've got one from the ankle down to the foot, and then another one from the foot to the toe, and that allows us to do more complicated things, such as we're having the toe lift or having the ball of the foot go up and down. And in order to sort of get that effect, you have to group the IKs correctly. And basically, when you group these IKs together, we end up getting different pivot points. So for this toe lift group, it's solving basically from this pivot here, but solving for the toe. So when we rotate, when this is affected, it's actually only rotating the X on this pivot here, but it's by grouping it, we've created that pivot for the IK. And the same goes for the ball lift. So in this case, we've only got it this group being affected. So when we lift the ball of the foot, I mean, it's still solving for it and manipulating them, but it's only based around the pivot, which is on this ankle joint here. Now once you've grouped, the IKs are all grouped and the pivots have been set for each group, we can go in and add some little things to the controllers. Unlike before, I didn't touch on set-driven keys before, because I ended up using expressions to essentially create the same effect. However, with the character, set-driven keys work better because you end up getting into a lot of complicated things. Now, what set-driven keys allow us to do is have an attribute over here, and we can create basically a value, minimum and maximum. So for the sake of examples, the toe lift, for example, has a maximum of 10 and a minimum 0. So between all the integers between 0 and 10 affect the X rotate. But all that's been done is, essentially, if you think of an animation, we've keyed on value 0 that this toe lift group here is rotated on nothing. So on frame 0 there's no rotation. Then we come over here. Actually, I'll bring up the set driven key box, so we can essentially, this is the driver, so the controller is the driver, and what's being driven is whatever we want. So in the case of the toe lift, we want to drive the toe lift attribute on the X rotate of the toe lift. So first we'd go in, key what happens at the value of 0. So on 0 we obviously want no rotation, and then we'll come in, bring the value to 10. Obviously this wouldn't have animated because we haven't set it. Come back to the toe lift and then rotate it. So we rotate that, and say we set the value, it's like, oh yeah, we want it to rotate that far. We'd then key the current, it says key the current relationship for the driver to the driven attribute, and that's basically what it does. So when you have a value of 10, it's actually rotating that negative 20, but whatever keyed value we set that at. And that is pretty useful when you want to it saves you a lot of hassle. I would save the animator a lot of hassle not having to have a controller for here as well, whereas it's a lot easier just to say have it here and then these attributes, and we can just have it up 0 to 10. We've also got roll, so the foot rolls on the Z, and we've got it on the Y. and that allows us to be quite, you know, it limits, but again you've still got the access to all the controls. So I'll just show off the foot again. So this is then, this controller is then parented to the groups, so the whole foot is affected by the controller, and on top of that we've got these attributes to play around with, and we don't mess up the bones again. We can just set everything to 0. Just the last two controllers, one to control the hips, and that just rotates the hips or moves them up and down, just kind of a necessity. And same for the right foot, same thing again. So once the IKs and bones and joints and controllers and attributes and set driven keys are all done, we can begin testing or applying the skinning to the mesh. So here we've just got a basic character mesh, and if we now move the controllers, we can see this is it's deforming the mesh quite nicely. However, like I said earlier at the beginning of the video, it's a bit more complicated than the car, since we're now dealing with more organic deformation. So if we bring this leg up, one common problem is how the geometry at the knee bends inwards. When you apply the skinning by default on the smooth bind, it actually sort of has this effect where it doesn't collapse on itself, it rather tries to stretch the geometry, so this part of the leg actually gets thinner, and it's not the effect you want. So you can do it one of two ways. You could either use the component editor, or preferably, because this is organic and we want to, you know, assign the weight fairly, you know, in a nice gradient. Ideally you want to weight paint. I prefer weight painting definitely on organic characters, organic things. That way we could paint in the different gradients and then change how things stretch. So in the case of this leg, I'll just pull this down. We basically just want some verts to kind of get squashed into the, well, basically have this, rather than try and smooth it, try and pull, ideally want them to, the lower bone to pull the verts from the upper part, and vice versa, so we get this nice squashing effect, rather than like it trying to stretch and keep the geometry built. And even though in theory the geometry is intersecting one another, you won't really see it, and it kind of looks like, if it, you know, if you think about the clothing creasing, that would kind of be the most realistic effect. So that's essentially what I've done so far. Right now the weight paints are still a bit iffy. I mean, right now I'm just going around tweaking things. So originally there was, when you first do the bind, some of this leg gets influenced by the other side and vice versa. So originally when you pulled the leg, some of these verts would stretch across to, because they're being influenced by the opposite side bones. So that's one thing you have to go in and tweak. So you have to make sure that nothing's sort of being affected by something it shouldn't be. And it's just a matter of playing and tweaking and testing. So, you know, making the character crouch and then maybe stretching a leg, you know, to its extreme, and see if there's any problems. And so far I haven't found too many major problems, and if there are, it's just a matter of, you know, tweaking the weighting and essentially how the mesh deforms under the influence of the armatures. So yeah, that's about it at the moment. The next endeavour is to try and get some arms rigged, and that essentially will be similar to the legs, except we've got to deal with these fingers, which is going to be fun and a bit of a challenge, but it'll be interesting. And yeah, that's about it. I hope you enjoyed the video, and I will have a update in the future.